Okay, so we're going to start with number 7. I wasn't sure if the previous stuff recorded properly, but it looks like it did. So we're going to start with problem number 7. It says, okay, we're going to start with number 7, which initially wasn't one that you could do because he changed the textbook. It used to give values on the table up to 15, but now it only gives the values to 8. So the new number 7 says a law is favored by 90% of voters. So that is going to be your P. P is equal to 90%, which is 0.90. And then it says, suppose 8 voters are randomly selected. So that's your N. N is equal to 8. Okay, and in part A, it says, find the probability of getting 6 voters in favor of the new law. So that's your X. X is equal to 6. And although people like the calculator, it's actually easier to use the table and faster. And so you're going to go to table A1. It's not on the formula card if you bought one. It's just in the back of the book. And we're going to go down to the section where N is 8, which is at the very bottom. And then X, the second column, is X equal to 6. And then we're going to go over to 90, 0.90. And the value that's there, the P of 6 is equal to 0.149. And that's it. That's all you have to show. Now let's go on to part B. Part B says find the probability of getting at least 6 voters. And this is a little tricky. It's the probability that X is greater than or equal to 6. A lot of students think that's you use less than, but you don't. If you want at least of something, if you want at least a B in this class, would you be happy with a C? No, because you want a B or higher. And at your next job, you want to make at least $15 an hour. Would you be happy with 10? No. So at least means that amount or higher. So the probability that X is greater than or equal to 6 is going to be the probability of 6 plus the probability of 7 plus the probability of 8. And we stop at 8 because that's what our N is. It can't go any higher than that. And so the 3 numbers, they'll actually be in a column. We already have the probability of 6. That's 0.149. The probability of 7 is 0.383. And the probability of 8 is 0.430. And so you're going to add all of those up. And that total is, what is it? 0.962 equals 0.962. Okay, and like I said, you can use your calculator on this one if you want, or the table. Either way, I think the table is easier, but you can use your calculator if you want. Now we're going on to number 8. And on number 8, you have to use the binomial probability formula. You cannot use your calculator. You have to show the work. Okay, so number 8 says, a company manufactures calculators in batches of 64. So that's going to be our N. N is 64. And then it says, and there is a 4% rate of defects. So that's our P. And 4% is equal to 0.04, not 0.4, 0.04. Be careful on that one. And we're also going to need Q. And Q is 1 minus 0.04, which is 0.96. Oh, let me do that part again. It didn't seem to come out very well, did it? Okay, I'm just going to redo that because it looked kind of not very good. So Q is 1 minus 0.04, which is 0.96. Okay, that worked better. Okay, in the binomial probability formula, there is one on the formula card, but I don't like that one. It's got all the factorial exclamation points. Instead, I prefer to use this formula. The P of x is equal to Cnx, P to the x power, and Q to the n minus x power. You do not need to memorize that one. I will write it on the board during the midterm exam. Okay, so we're going to replace every letter with a number except the capital P is going to stay capital P and the capital C is going to stay capital C, but everything else will be replaced by a number. Oops, I need X, don't I? So that was in the next sentence, which said, find the probability of getting exactly 3 defects in a batch. So that's your X. X is always the question. So we're finding the probability of 3. N is 64. X is 3. P is 0.04 to the 3rd power. And then Q is 0.96 to the 64 minus 3 power. Okay, so to do the first part, okay, the C stands for the combination formula, and you can do that on your calculator by pressing Math on the TI calculator. Almost all calculators have this, so I can help you find it if you don't have a TI calculator. But you push Math, which is on the left side, the 3rd button down, and then you arrow over. Whoops, we got to do something else first. Sorry, never mind. First, you have to put in the 64, and then push Math, and then arrow over to probability, and you want choice 3. You want this NCR. So you just push 3, and then you have to put X in, which is also coincidentally 3, and then enter. And it turns out that that is equal to 41,664 times 0.04 to the 3rd times 0.96 to the 61. Okay, and the next thing you're going to write down is the answer. You don't want to show all these individual parts. The author recommends that, but I disagree with him because frequently the little parts come out in exponential notation, and it's a little... okay, so you've got 41,664 times 0.04 to the 3rd times 0.96 to the 61st power, and the answer comes out to be 0.221. You can check this on your calculator by going next to the clear button is VARs, which is variables, and above that it says distribution. So you can go second distribution and then scroll down to binomial PDF. On some calculators it's A, on others it's 0, and then the numbers that you put, there's a parentheses when you hit binomial PDF, and the first number you would put in would be your N, which is 64, and then you have to use a comma, and then you're going to put in your P, which is 0.04, comma. You don't have to put Q because the calculator can figure that out, and then you have to put X, which is 3, and then close parentheses, and it gives you the same answer. So that's a check. Okay, now we're going to do the very last one, number 9. And it says, an educational testing corporation has designed a standard test of mechanical aptitude. Scores on this test are normally distributed with a mean. So let's write that down. This is number 9. The mean, mu, is equal to 75. And the standard deviation, sigma, is equal to 15. Okay, part A says if a subject, and I'm going to emphasize that by saying that n is 1. If a subject is randomly selected and tested, find the probability that his score will be less than 100. Less than 100. Okay, so you got a handout for 6.3 that says finding probabilities in non-standard normal distributions. It is a 5-step process. The first step is to put the question into probability notation. So capital P parentheses x is less than 100. In order to use table A2 in the back of the book, which is the standard normal distribution, and in the standard normal distribution, the mean is 0 and the standard deviation is 1. But we don't have that, but we're going to use that table. So we have to standardize our units, or as I call it on the handout, changing from the x world to the z world. And steps 2 and 4 are scratch work, so I do them over to the side. So step 2 is z is equal to x minus mu over sigma. X is 100, even though it says less than, it means less than or equal to. So x is 100 minus 75, and then that is divided by 15. Make sure you do this on the calculator because, believe it or not, it's a little tricky. You have to make sure that you either put parentheses around the numerator or you do the numerator, get the answer, and then push divided by. So, and we do round z to 2 places. I put it in bold on the handout twice. You round z to 2 places. And so it comes out to be, it's 1.66666, and when we round to 2 decimal places, it's 1.67. Then we're going to go back and rewrite the question in the z world. So x changes to z, and 100 changes to 1.67. And I'm going to mark that here. X becomes z, and 100 becomes 1.67. Okay. Step 4 is to draw the picture in the z world. In the book, they have both horizontal axes, but I just like to draw the picture in the z world. And we know that 0 is in the middle, positives to the right, negatives to the left. So 1.67 is approximately right there. And now we have to shade. And since it said less than, we shade to the left. Less than is to the left. And then we're going to go to the z table. And we are going to look at the picture. Of course, we're using the positive. Remember, there's 2 z tables, positive and negative. We're using the positive table. And we look at the picture at the top of the table and compare that to the picture that we drew. And they are similar. And so we can just get the number out of the table. But you have to break it up. You've got to go down the first column to 1.6 and then across the top to 0.07. Because if you take 1.6 and 0.07 and add them up, you will get 1.67. So this area is 95.25. And that makes sense. We know that the area under the whole curve is 1, and we clearly shaded in more than half. And so we get an answer that is more than half. Okay, part B. Part B says, if a subject is randomly selected and tested, find the so it's a subject again. I'm going to emphasize that n is 1. Find the probability that his score will be greater than 95. Greater than 95. Okay, step 1 is to put the question into probability notation. So capital P parentheses x is greater than 95. Step 2, change from the x world to the z world using the formula z equals x minus mu over sigma. And x here is 95. The mean is still 75. And the standard deviation is 15. So when you do that one on your calculator, you get 1.33. And then we go back and we rewrite the question in the z world. So it's probability z is greater than 1.33. Again, x is replaced by z, and 95 is replaced by 1.33. Okay, step 4 is to draw the picture. And 1.33 is, I don't know, let's say right here. Close enough. And this time we want greater than, so we're shading to the right. The problem is that when we hold up the table and we look at the picture at the top of the table, it does not match what we drew. In fact, what we drew was the opposite. So when we look 1.33 up in the table, it's going to give us the area to the left. And that's not what we want. We want the area to the right. But we do know that the area under the curve adds up to 1. So to get our region that we want, it's going to have to be 1 minus whatever we get for the area. And so it's 1 minus 0.9082. And when you subtract, the answer is 0.0918. And that makes sense because we shaded in less than half of the graph. And we got an answer that was less than half. The answer of 0.9082 for the area that we shaded in would not make any sense. So you have to remember on this one that you have to subtract it from 1. Okay, so I'm going to write down the mean and standard deviation again. So we have it up here. The mean mu is equal to 75, and the standard deviation sigma is equal to 15. Okay, part C says, if a subject, so again, I'm going to emphasize the fact that n is 1. If a subject is randomly selected and tested, find the probability that his score will be between 50 and 100. Okay, step 1, put it into probability notation. Capital P and parentheses, and then it's 50 is less than x is less than 100. That's what the between notation looks like. Step 2, I'll do this up here. Change from the x world to the z world using the formula x minus mu over sigma. And we're going to have to use the formula twice. The first time, we're going to convert the 50. So it's 50 minus 100 divided by 15. And that comes out to be negative 1.67. And then Z2 is going to be oops, I'm sorry, I made a mistake back there. I used 100 when I shouldn't have. It's actually 75. My apologies. It's 50 minus 75. Okay, now that makes more sense. So it's 100 minus 75, and that's all divided by 15. And that one turns out to be a positive 1.67. Okay, so we're going to come back over here and rewrite the question. But 50 is replaced by negative 1.67. And x is replaced by z. And 100 is replaced by positive 1.67. The drawing of the picture in the between ones is not as important because between problems are always done the same. But we'll draw it anyway. So, let's say here, positive 1.67, and over here is negative 1.67, and we want the region between. And the way to do that is to look up the number furthest to the right first, which is 1.67. And when we do that, we get 0.9525. And then when we look up negative 1.67, we get 0.0475. And we subtract. That's the way you do between problems. You subtract. It doesn't matter if both of the z-scores are positive or both of the z-scores are negative or one's positive and one's negative like we have here. You always, always subtract. So 0.9525 minus 0.0475 is 0.9050. Okay, let's go on to D. Now, D is different. I hope I have enough room here. We'll see. Because D says 80 different subjects. Remember in all the other ones, I emphasized the fact that n was 1. So in this problem, n is 80. 80 different subjects are randomly selected and tested. Find the probability that their mean is below 71. So this problem is referring to the central limit theorem. And so the only change, we're going to have to make a little adjustment on step 2, but other than that, it's the same as the first 3. And the reason we're working with means is that if your population is not normally distributed, you work with means. You can take groups of 5 or groups of 10, or 30 is kind of the number that they like. And then you find the mean of those 30, and then you take another group of 30 and find the mean. And the means will be normally distributed, even if the original population is not normally distributed. They have pictures in the book. Not the best. I like the pictures in the past. Anyway, here we go. Okay, step 1. Find the probability that the mean. So I'm going to call it x bar. If you don't put the bar, I don't take points off. But just to let you know that we're working with means. Below sounds like less than 71. Step 2. Change from the x world to the z world, but we have to adjust this formula. And in the denominator, it is sigma divided by the square root of n. So, let's see what we get. We get 71 minus 75 divided by 15 divided by the square root of 80. Now, the best way to do this on your calculator is in one step. And you're going to do that by putting parentheses around the numerator and parentheses around the denominator. So it's parentheses, 71 minus 75, close parentheses, divided by new parentheses, 15, divided by square root of 80, and then close parentheses. And we do round to 2 places, so it's negative 2.39. Negative 2.39. And then we're going to come back over here and rewrite the question in the z world. x bar is replaced by z bar, and 71 is replaced by negative 2.39. Step 4, the drawing of the picture. And negative 0, negative 1, negative 2, oh, I don't know. Say right here, negative 2.39. And we are shading to the left because it is less than again, or below. Okay, so we go to the negative z table, and we look at the picture at the top of the negative z table, and it does look just like the picture that we drew, so we don't have to worry about adjusting anything. So you're going to go down the first column till you get to negative 2.3, and then you're going to go all the way over to 0.09, and the area is 0.0084. Okay, last one, and let me write down again for number 9 that the mean mu equals 75, and the standard deviation sigma is 15. And this is part E. This is the last question on the midterm, but it's also the first question on the final. There's a little bit of overlap here. So the skill that we use for this one, we need for the first one on the final. And the question is to find P30. P30, which is the 30th percentile. And P30 means that 30% are below, and therefore 70% would be above. The percentile always tells you the percentage that is below. This is on the handout, this is the very last one. It's finding values in non-standard normal distributions. It's kind of like going backwards. So in this one, the first thing that we do is draw the picture. And we have to make a line, either to the left of center, in the center, or to the right of center. This one is going to be in the middle would be the 50th percentile. So the 30th percentile is to the left. And so this portion is 0.30. I don't know if that looks very good. And the portion to the right, that looks okay, is 70. So this is the z value that we're going to be looking for. And we notice that it's going to be a negative z value because it's to the left of center. Step 2, express the area to the left of the line above z as a 4-digit decimal. So basically, we're just taking the 0.30 and adding 2 zeros to it. And now we're going to go to the z table, into the body of the z table, not down the sides and across the top, but into the body of the table where all the numbers are 4 decimal places long. And we need to find the value that is closest to 3,000. So what I generally do is I pick a column, I go down that column, and when I get close to 3,000, then I start going right and left. And let's see where we're going to end up here. Okay, so there are 2 numbers. I'll do this over to the side. We have a little bit of room here. One value is 0.3015, and another value is 0.2981. And our value of 3,000 is between those 2. So we want to pick the one that is the closest, and 3,015 differs by 15, and 2981 differs by 19. So we're going to pick the one that is the closest, which is 3,015. And once you've decided that is the number that you're going to use, then you have to look over to the left and look up to see what z-score corresponds to that value. And so over to the left, it says negative 0.5 Let me just find it. I lost it here for some reason. Okay, yeah, negative 0.5, and then up above it says 0.02. So this is negative 0.5, and this is 0.02. And you're going to add those two together, so it's 0.5 and 0.02. You're going to add them and get 0.52, but it is a negative. You don't find the difference between those numbers. You add them and then make the answer negative. So coming back over here, 3,000 is closest to 3,015, and the z-score that corresponds to that would be a negative 0.52. Okay, now we have to find x, and there's two different ways to do that. So first, I'll do one way over here. This is the last step, number 4. You can use the formula z equals x minus mu over sigma. And we do know that z is negative 0.52, is equal to, and this time it's x that we want to find, minus 75, and that whole thing is divided by 15. And now, how does that look? Nice, it's okay. As we say, the only good fraction is a dead fraction. So let's go into the blue for a minute, and we're going to multiply both sides by 15. On the right side, the 15s are going to cancel out. And so what you get over there is x minus 75. And on the left side, you take your calculator and you multiply 15 times negative 0.52, and it turns out to be negative 7.8. And now to solve for x, you will add 75 to both sides of the equation. And when you do that, you get, let's see, you get 67.2. 67.2 is equal to x. It's the only algebra we do the entire semester. Now, if you really hated that, there's an alternative formula, which I'll do over here. You can use this formula, x is equal to mu plus z times sigma. But that formula is not on the formula card, so if you want to use it, you need to memorize it. And so x would be 75 plus a negative 0.52 times 15. And of course, that would come out to be 67.2. Okay, so either one of those formulas will work. And that's it. Good luck. And see you later.